Greetings, fellow mathematicians! We're going to take a look at a trig integral that involves powers of sines and cosines. Now, since this is our first problem on trig integrals, let's go through some of the basics. The most important thing for you to realize is basic u-substitution with some trig identities thrown in. Now, there's a lot of different possibilities that you can memorize. Even powers do this, odd powers do that, sines, cosines, tangent, secants. It's a lot, but your basic idea for substitution, split off something for du. And you can work from there. What you split off for du, think what would be the u, or substitution, that gives that. That's going to guide you through almost all of these problems on trig integrals. Now let's go ahead and get to this one in particular, which involves powers of sines and cosines. And as long as there is one odd power, these are very easy. We're going to split off one power from the odd factor. And if you take a look at here, we have an odd power of cosine. Let's pull off one factor of cosine of x. Let's rewrite this first. We're going to keep sine to the fourth power the same. I'm going to split off one factor, leave me with cosine squared. And I'm going to put the factor of cosine of x that we're splitting off right next to dx. So let's write that as cosine of x dx. Now, if you kind of split off the right factor, what you should find is you'll be able to convert, using your substitution, the other pieces using Pythagorean identities. And your Pythagorean identities, they involve squared trig functions. So as long as you split off something and you're left with even powers of trig functions, those can be converted using Pythagorean identities. Now let's get through what our substitution is. Here, cosine of x dx, we're going to think of that as being our du. Again, what you split off, you want that for your du, or differential. So what would differentiate to cosine? Sine of x. So let's try our substitution, u, as sine of x. And from here, it's going to be basic u-substitution. Calculate your differential, du. The derivative of sine is cosine of x. And here we can convert some of the factors or terms in our integral. Cosine of x dx becomes du. Using our substitution, u equals sine of x, we can convert sine to the fourth power of x as u to the fourth. But the remaining work is we have to convert everything from x's to u's. So how, with our substitution, u equals sine of x, are we going to convert cosine squared? That's where your Pythagorean identity comes in. So let's go ahead and work that out right below here. We want to convert cosine squared to something involving sine. And this is very common. You'll want to use your basic Pythagorean identity in one of these two alternate versions. For this problem, the one that we want to use is the one on the bottom here, converting cosine squared to 1 minus sine squared, because we can use our substitution there, u as sine of x, to rewrite that as 1 minus u squared. So let's put this all together. Make use of your Pythagorean identity. And now we use our substitution. We're going to replace u for sine of x. And as long as you're comfortable with powers, sine squared of x can be thought of as sine of x squared. Again, this is our first problem, so I always like to do this in my Calc 2 course. Now you can plug in u for sine of x inside there, and you'll get 1 minus u squared. All right, so that converts this part, cosine squared of x, that converts, using our substitution, to 1 minus u squared. All right, and from here we can write down our conversion integral from x to u. We have all of our factors. We have a factor of u to the fourth. We have a factor of 1 minus u squared. And then we have a factor of just du. Just be careful. You might find with your choice for du or u that there's a negative at the end there. Just be careful of that. All right, from here, the integral should be very straightforward. We can just distribute. And it looks like we get a really simple integral here. Looks like we get u to the 4th. And be careful, add your powers. You'll get u to the 6th. And we just integrate those each term by term using the power rule. So here we'll get 1 over 5 times u to the 5th, and then minus 1 over 7 times u to the 7th power. And now we just substitute back our choice for our substitution. We used u as sine of x, and we just plug that in both those spots. So we're going to substitute u back in terms of x as sine of x. And again, be careful with your powers here. In your Calculus 2 course, you almost always use the shorthand notation where we have sine raised to a power, but we interpret that as sine of x raised to that power. So if you plug back in here, we can rewrite our two terms, 1/5, and we're going to use the power notation to rewrite that as sine to the 5th of x, and then minus 1/7 times sine to the 7th power of x. And there we go. We get our antiderivative using a basic u-substitution, but the extra part here was knowing what to split off and then converting the other pieces with a Pythagorean identity. All that work is standard for almost every single trig integral problem. So just make sure you're aware of that, split something off, and use a Pythagorean identity. Hope you enjoyed the problem. If you did, support the channel, like and subscribe.